Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at creating a thread which will update our surface regularly. So we want to do frame by frame animation, and that means that we want what's called a game loop somewhere, and that's kind of a loop that runs continuously and updates our surface probably as often as possible. And so we're going to implement that in this tutorial. And I don't want to turn this into a tutorial on game programming as such, although we are going to cover the basics, partly because I've never written a professional kind of game. So I'm going to try to keep it with the Android, but inevitably in discussing animation we're going to have to discuss some stuff that's pretty much used in more or less any kind of game. And there's nearly always going to be some kind of Android twist on what we do, although I will show you some kind of things that are just kind of generic game programming things and not Android specific. So I'm going to create here a new class, not here because that's the wrong project. Here I'm going to click my package. I'm just bunging everything into the same package for this tutorial again, and I'm sure it's possible to structure this code better than I'm going to do, but I just want to try to keep it really simple for demonstration purposes here. So I'll create a new class, and I'm going to call this Game Runner, and this is going to be a thread whose responsibility is to update the surface frame by frame, at least sort of 25 times a second or something, if possible. So I'm going to say public class Game Runner extends thread, and I'm going to use the thread class here. And you might wonder why I don't want to use async task here, and that's because I want to bypass here the kind of normal Android mechanism which you find in pretty much any GUI system of all these systems usually have a way of posting updates to a kind of a thread which processes a queue and paints the user interface when necessary. And because this is going to be a game, and this is true for any kind of really serious animation, you want to force updates to happen when you say they should happen. So you don't want to just post an update to a user interface thread and let it update the user interface when it feels like it's, when it feels like it's a good idea. You want to say, right, now it's time to update the user interface, do it. And that's why we're creating a kind of separate thread here. It's a thread that is going to directly update the user interface, and async task is not intended to do that. It's intended to avoid directly updating the user interface, which will cause problems under most circumstances. So I'm going to just right click here and go to source override implement methods, and I'm going to override the run method. And if you want more information about multi-threading, on www.caveofprogramming.com you can find a free course on multi-threading, but we're only going to be using really simple multi-threading here, basically nothing complex. And so I've got this run method, and this is the method that's going to run my game loop. And I'm going to, up here, I'm going to have a private volatile boolean called running, and I'm going to set that equal to true. And down here in run we're going to say while running, and we're going to draw stuff here, draw stuff and update the game. And the reason this is volatile is because threads can, in theory, cache variables. They won't always do it, but they can decide to cache a variable if they see that that variable is not updated from the thread itself. And so if you have two threads accessing the same variable, you need to at least make it volatile. And if it's something other than a boolean, like an integer, you're going to have synchronization. But here it's only going to be a boolean variable, and we're going to make it volatile so that all threads can see the current state of that variable. And that's really just a hypothetical danger, and in practice this will probably work without volatile, but just to be doubly sure, we'll put that in there. And I'm going to make this game draw at full tilt, so it's going to refresh the screen as often as possible. But just for the moment, let's put in a thread.sleep to kind of slow things down a little bit. And let's say thread.sleep, I don't know, 300. So that's like roughly 3 times a second that this loop's going to execute, and I'll handle the interrupted exception there. And for demo purposes in this tutorial, I'm just going to have a log.d in there. So let's say log.d. That's really why I'm putting thread.sleep in. I don't want to output log messages as fast as possible, because that will really slow down my Eclipse. And if you literally want to make a game, then you probably don't want that in there. You probably want the screen to refresh as often as possible to make it as playable as possible. But on the other hand, if you want to do animation that's part of some kind of application that isn't a game, and it does other things besides besides refreshing the screen and drawing the screen, then you might well want a thread.sleep in there, so that your application isn't absolutely doing animation full tilt, but will hopefully have the kind of energy, the CPU cycles, to do other stuff at the same time. But here we're not going to worry about that, because I want it to go full tilt and to use as much of the resources of the phone as possible to actually make my game work. So I'm going to take this out later on, but I'll put it in for the minute. And we need some way of stopping this by setting the running volatile Boolean variable to false. So I'm going to give this a method, public void shutdown. We can't call it stop because thread already has a method called stop. And I'm going to say public void shutdown, and in there I'm just going to say running equals false. And if we didn't make running volatile, in theory this could be ignored if it's called from another thread, which it is going to be called from another thread, but it is a theoretical possibility. And now back in my game view here, I'm going to create let's have a private variable that holds one of these game runners, which I'll call runner. And what I'll do is, when the surface is created here, then I want to start my game running. So I want to say runner equals new game runner, and then I call runner.start, and that tells the thread class to go to the public void run method and to run it, and that's going to enter our game loop here, which ultimately is going to do our animation by drawing the screen. And in surface destroyed, I want to stop runner from running. So I'm going to say if runner is in fact yeah, I think that's right. If runner is not equal to null, let's say, let's check that it's not null, and I'll say runner.shutdown. So we're telling it to shut down. And now what I want to do is I want to wait for it to shut down, and the reason for that is that I want to, the game runner is going to tell the game to draw on the surface, and I want to not allow my phone to go to another application until this runner has stopped drawing, because if it were to go to another application without shutting the thread down, the drawing code might still try to draw on the surface, which no longer exists, and it might crash. So I want to make very sure that this method will not exit until the game has successfully stopped drawing, which should be very, very quick. We should be talking about milliseconds here, hopefully. But to be on the side of caution, let's make sure that we wait for the thread to exit here. And to do that, I'm going to say while runner is not equal to null, and in there I'm going to say runner.join, and this is a method that waits for the thread to terminate, and that throws an interrupted exception. So I'm going to surround with try catch, and underneath runner.join I'm going to say runner equals null. And what this does is we're going to say runner.shutdown, and runner.shutdown is setting running to false, and it should mean that that loop is going to terminate pretty quickly. And then we say, okay, while runner is not null, which it isn't because we just called shutdown on it, and in fact we checked that it wasn't null up here, we're gonna in a loop we'll wait for it to finish, and even if join gets interrupted somehow, if it does, we'll catch an interrupted exception. And in fact, let's just get rid of the stack trace print, and we'll go around the loop again, and eventually we will successfully wait for the thread to finish without it being interrupted, without join being interrupted. And once it's actually finished and we've successfully run join, which just waits for that thread to exit, then we set the runner to null, and then we stop trying to wait for it to finish, if that makes sense. And whether all this is actually necessary, I'm not completely sure, but I've tried some variations on this code, including trying to interrupt the thread rather than having this shutdown mechanism with thread interruptions, and I couldn't get it to work. And in the end I concluded that since this code is a popular way of doing this, and since it works, I'll stick with this. So I think that should all work. When a service is created, we'll create a new thread object and we'll run it, and when the service is destroyed, we are going to shut down the thread, and then we're going to wait for it to finish. And what I'm doing is I'm not doing any drawing at the moment, I'm just outputting a log message, so we should be able to check that that works. And as I said, I think in the last tutorial, it's really worth sorting this out and making sure that all this code fully works before you go on to doing the rest of your game, because otherwise you can have a real headache trying to figure out what's going on. So I've run my application, and we've still got that code in there, and it doesn't draw unless I touch the screen. So I'll touch the screen, and there we go. And even though the onTouch is in another thread, it's in the main user interface thread, it's cooperating nicely with my other thread here, which is start putting this running message actually. And so scroll lock is off, so we should be seeing the latest kind of thread.running here, and we can see the time changing here. And now if I just go, let's go back to the screencast. If I just go to the home screen, we see that it stops, so it's very nicely stopped. And if I go to my recent apps here, then it started again, which is great, and again I can touch the screen and make the drawing appear. And another thing that you should definitely check is go to your home screen, and if you look at your recent apps, at least this is how my phone works, and I think this is standard on all Android devices, but I'm not really sure because I've only got the one Android device. And if I now swipe away my application, I've exited the application, and now I can go to my all apps view and start my application from this screen by touching it at the top there. And once again we see that the thread started again and it's behaving nicely. So you should check all of that stuff, and also check that if you call your phone, check that it doesn't crash. And I've checked all that with this code, so it should work, but I've only checked it on this one device, so I'd recommend that you give it a go. And I haven't been able to get this to work really in a good way in an emulator, and stuff like games is a lot easier to run on a real device than an emulator, which is never going to reflect real life fully. Okay, so that's it for this tutorial, and until next time, happy coding.